Alright, so let's try to look at the question focusing on the periodic table. So the elements x and y, and elements x, y, and z have the following nuclides. So nuclides including the mass number and the proton number or the electron number. So these chemical symbols that they have used here, they are not original chemical symbols for these elements. So question A, draw the dot and close diagrams showing outermost shells only for the compounds formed by x and y. So for you to answer this question, you have to understand to say you have to show outermost shells only. So let me start with x. In terms of the electronic configuration, since we have 9 electrons, that is 2,7. For the outermost shell electron to be stable or for it to be full, needs how many electrons? 8 electrons. So this one needs 1 electron. Then for y, what do we have? We have 11, so it is 2,8, 1. Okay, so just a brief explanation. Group 1, group 2, and group 3. These are metals. Okay, and metals, they lose electrons. So they lose electrons. Group 4, group 5, group 6, and 7. These ones, they gain electrons. Okay, so they gain electrons. Whilst group 8 is stable because it has 8 electrons in its outermost shell, so it is stable. Right. Now, apart from that one, like I said, the number of electrons in the outermost shell, they are going to determine the group where the element is found. So this one is found in group 7, this one is found in group 1. So this one is a metal and this one is a non-metal. Right? Then again, the number of electrons that an element needs for it to be stable, or the number of electrons that an element is going to lose for it to be stable, they determine the valence. So this one, for it to be stable, it needs how many electrons? 1 electron. Then for this one to be stable, it needs to lose 1 electron. Okay? So meaning to say the valence of x is 1, the valence of y is 1. So there is an important thing that you have to know here. So the valences, they swap for you to come up with the chemical formula. So if they swap, what are we going to have? We're just going to have xy. So we have a non-metal and a metal. The bonding that involves a metal and a non-metal, it is called the ionic bonding. And usually ionic bonding compounds, they conduct electricity because they contain ions that can easily transmit electrons. So those are the things that you have to know. So first you have to write the chemical formula using this assumption. Then the last thing, if you count the figures of the electron configuration, those are going to determine the period in which an element is found. So if you count 1, 2, this one is found in period 2. If I count 1, 2, 3, this one is found in period 3. This is what I mean. So let's answer this question. Remember, only outermost shell electrons. So let me start with x. So for x, it has how many electrons? 7 electrons. So I'm going to use a close. Then for it to be stable, it needs how many electrons? 1 electron. So I'm going to put a negative here. So those elements that gain, we put a negative according to the number of electrons that element needs for it to become stable. So if it needs 2 electrons, we have to put negative 2. If it is losing, we put plus. So let me just draw for y here. So this is y. So for y, I'm going to use now dots. So it's just one dot because it has one electron in the outermost shell. So since it is losing one electron, I'm going to put a positive here. Then what are we going to have? This one is going to go there. Then what are we going to have here? Let's see. So here we are going to have 8 now electrons. But remember, one is going to be a dot, which is coming from Y. So this is X. So this is our final X that we are going to have. Then our final Y, remember, 1 has gone. So if 1 has gone, the electron configuration now is going to be 2,8. So we have 8 electrons in the outermost shell for X. Let me say for Y, not X. So we're going to use the dots 1, 2, 3, 4, 5, 6, 7, 8. And remember, electrons they have to be paired. So I need to put a positive here. So this is how you're supposed to draw that. Then X and Z. Remember X and Z. For Z, for X it is 2,7. For Z, it is having 6 electrons. So meaning to say, we need to have 2,4 because it is having 6 electrons. Now, like I said, the number of electrons that an element needs for it to become stable, or is going to lose or gain for it to become stable, determine the variance. So for this one to become stable, it needs how many electron? 1. That's 1 as the valence. This one needs how many electrons for it to become stable? This one needs 4 electrons for it to become stable. Okay, let me just erase this one. Okay, so for this one to become stable, it needs how many electrons? 4 electrons. So that is the valence. So like I said, the valences, they swap. So this one is going to be here, and this one is going to be here. Okay, so this is what we are going to have, or you can say Z, X, and 4. So we have how many X? There are 4. How many Z? 1. So let me just draw Z. So Z is going to be at the center. Okay, let me just do this. So what I'm going to do here is, since we have Z at the center, and Z has how many electrons? 4 electrons. For X, there are how many? 4, so I'm going to draw them here. This is because here we are dealing with non-metals. So non-metals, they share electrons, and that is covalent bonding. Covalent bonding is the one that involves the sharing of electrons. So this is X and this is X. This is X and this is X. So each single X has this electron configuration. So this one has this, this one has this, this one has this, this one has this. So let's start with Z. Z has 4 electrons. So Z is going to contribute 4 electrons. It's going to contribute 1 electron to this X, another one to this one, another one to this one, another one to this one. So we don't have any electrons for Z. It has now shared all the electrons in the outermost shell. Let's come back to X. X is also going to contribute 1 electron, even here is going to contribute 1 electron, even here is going to contribute 1 electron, here is going to contribute 1 electron. But remember to say, if X is contributing 1 electron here, just this part here, how many electrons are going to remain? From 7 you remove 1, you're going to remain with what? 6. So each X here is remaining with 6 electrons. So let me put 1, 2, 3, 4, 5, 6 plus this to 8 stable. 1, 2, 3, 4, 5, 6 plus this to 8 stable. 1, 2, 3, 4, 5, 6 plus this to stable. 1, 2, 3, 4, 5, 6 plus this to 8 stable. So this is how you're supposed to draw. Compare the electrical conductivity of the two compounds in A Roman number 1 and A Roman number 2. So this one is focusing on the covalent bonding. Like I said, covalent elements, they don't conduct electricity. Ionic bonding or ionic elements, they conduct what? Electricity. So we are going to say X and Y conduct electricity, or they have high conductivity, while X and Z do not conduct electricity. Why? Because these, they don't have the ions to conduct the electricity, or the electrons to conduct electricity. Then question C is saying state the location of the periodic table of the location of the element X on the periodic table. So the location of X, if you look at the electron configuration, it has 7 electrons in the outermost shell. So meaning to say it is found in group 7, and group 7, they are called halogens. So found in group 7, or we can say they are halogens. Okay, thank you very much for watching, and remember to subscribe for more videos like this.